Hello everyone, this is Math 140, day 5. There's a lot of different things in module 2, so let's start with something relatively simple, and that's adding rational expressions with linear denominators. A rational expression is a fraction where numerator and denominator are polynomials. So something of this shape. And when we're dealing with them, the key is that the exact same laws apply that you're used to when you're dealing with fractions of integers. So we can multiply fractions as usual. We can add them and subtract them if they have the same denominator. And when they don't have the same denominator, then we need to bring them to a common denominator by multiplying and numerator and denominator by the same quantity. So let's do an example for this. X plus 1 divided by x minus 3, that's one rational expression, minus 2x divided by 3x plus 6. So to do that subtraction, we have to first do something. They don't have the same denominator. And here's the key piece of advice. Before you start looking for that common denominator, factor the numerators. Sorry. Factor the two denominators. Factor the two denominators. To find the lowest common denominator. So you can't do anything with x minus 3, but for the 3x plus 6, we obviously can do 3 times x plus 2. That's the beauty that we are just dealing with linear denominators, which means they both have degree 1. So that's relatively easy. The only way to factor them is a constant times another degree 1 polynomial. And now we can tell there is nothing in common between the x minus 3 and the x plus 2 and a constant, yet another factor. There is nothing in common. So the lowest common denominator, maybe that's called LCD. We can just state that we do it that way. Lowest common denominator that we are after is just 1 times the other, and we don't care if you factor it or not at this stage. This is a multiple of both, and it's the lowest degree multiple of both denominators. So all 3 of them multiplied up. And then we need to expand both fractions to have this denominator. So x plus 1 divided by x minus 3 is x minus 3 times x plus 2. And the top, x plus 1, gets multiplied by 3x plus 6, if I like it that way. Either way, I need to multiply both numerator and denominator by the same thing. And then I can go in and expand the numerator. This is the FOIL again in action. So we have a 3x squared. We have 3x And we have 6x for a total of 9x. And we have 1 times 6 is 6 at the top. Okay, now for the other one, that was a 2x divided by 3x plus 6. That's going to be x minus 3 times 3x plus 6. And the top is x minus 3 times 2x. Simplify that, expand it out, and you get 2x squared minus 6x divided by that same denominator. So one of them minus the other one, that's subtraction. We can now do that, and we should get 3x squared plus 9x plus 6 minus 2x squared minus 6x. And the whole thing divided by, so I squeezed it a bit, the whole thing gets divided by x minus 3 times 3x plus 6. It's not yet in the final form. It needs to be subtracted and simplified. So we have 3x squared minus 2x squared. That's giving me an x squared. We have 9x minus negative 6x. A double negative, that gives me 9x plus 6x for a total of 15x plus 15x. And finally, the plus 6 is all by itself, and that's it. Theoretically, it's possible that there would be a cancellation when you're adding more than 2 fractions or subtracting. But if it's just 2 and you had the lowest common denominator, this never happens. There's not going to be a possible simplification. This is it. And it doesn't matter because there is no simplification if we expand this out or not. Might as well just leave that denominator as is. There's various applications where it's actually beneficial to leave the denominator as is. Unless explicitly requested. It might be in the question itself, or you look at the example. Every time you do an Alex problem like this, they give you an example, a worked example, and just watch, do they expand this out? And I've just watched one and they didn't, which makes sense. They just leave that denominator. It's not simpler to expand it out. But I did an example with the subtraction on purpose because there's an extra feature which a lot of students often overlook, and that is when you're doing the subtraction, at this moment, you need to place a parenthesis around the second numerator. Think mental parentheses. So when you're subtracting the entire second fraction. If you didn't have that, then this negative sign would only apply to the 2x squared. This negative sign would only apply to that 2x squared and would not have an effect on the negative 6x. And, well, you get a wrong answer. So do that parentheses, and then follow the rules for resolving a parentheses with a negative sign in front of it, and you're safe. Everything's good. Okay, so that was this example. Now, a new example, and nobody wants surprises. I'm going to give away what the new example is about. It's about a common factor in the two denominators. So let's look at x plus 1 divided by x minus 3 plus 2x divided by 3x minus 9. So somebody who just takes a common denominator will take x minus 3 times 3x minus 9, and you get a right answer. That is not a wrong answer, but it's not totally simplified that way. It's also unnecessary work. Who wants to do unnecessary work, right? Nobody. And Alex will actually count that as wrong if it's not simplified. So what was my advice? Factor the two denominators. Can't do anything with x minus 3, but 3x minus 9 is 3 times x minus 3. And now we spot a common factor here and here. So my lowest common denominator, that's right, lowest common denominator is just 3 times x minus 3. That covers everything in play. Okay, it covers the 3, the constant 3, it covers the x minus 3, which takes care of both denominators. So we just need to do this. X plus 1 divided by x minus 3 is 3 times x plus 1 divided by 3 times x minus 3. And then the other one, the second summand, doesn't need any work. We can just straight up add them. And we get the answer, 3 times x plus 1 plus the 2x, and divide the whole thing by 3 times x minus 3. Yes, it should be simplified. That's what they wanted us to do. So this is 3x plus 2x, which is 5x. And the 3 times 1 is just a 3. That takes care of this. And 3 divided by x minus 3. And the whole thing was actually easier than the first example. But imagine we had done a common denominator of x minus 3 times 3 times x minus 3. So we would have had to work on the second one and multiply that by x minus 3, top and bottom. It would have made our life so much more complicated. Okay, don't do it. Brr. It's exactly the same as adding two fractions of integers and not using the lowest common denominator, but some other higher denominator. Don't do it. Okay, that is this topic.